something. So
Me too.
it's
I
cool.
think everybody really is better off when
Yeah,
they have something to focus on and can actually do it.
for sure. Yeah.
All right. Perform the indicated operation and state the domain.
Yeah.
So if f of x equals 2x minus 4 and g of x equals x minus 2, what's the sum of those?
Um. So for this one, it would it be 3x minus 6?
Correct? Good. By
Okay.
number 2, what's the difference of those?
Okay. So that's all you do
Uh-huh.
for those? Okay. Cool.
Well, for the first two, it
Or
gets
for the first, yeah.
more complicated as we go forward. But
Right. This would be x minus 2.
good.
Cool.
And 3.
And then this would be 2x squared plus 8. Uh,
No, but you're close. Remember, do not make this mistake.
okay.
And this is truly the most common mistake in algebra. I've read it, and all my students do it.
Okay.
That is not true.
Okay.
What you have to do is multiply x plus 1 times x plus 1, and it does not produce that.
Okay.
Okay?
Right.
Well, this is similar in
Mm-hmm.
that we're not multiplying. What do you suppose happens when my eraser stops working like this?
Does it do that regular or
Yeah, it
often?
does. Lately, it's been doing it real regularly. I wonder if maybe there's something wrong with this cursor I have. I don't know.
Yeah.
Ah,
Uh,
frustrating as heck. Okay, it kind of does it on a delayed basis.
oh,
Well,
gotcha.
if I'm multiplying it, I got to multiply 2x minus 4
Uh-huh.
times x minus
Oh, okay.
2. How do you multiply a binomial times a binomial?
Well, you FOIL it out.
Okay, FOIL that.
Okay. So it would be 2x squared minus 4x plus 8. So it would be 2x squared minus 8x plus 8.
Right.
Cool.
Notice that there is almost always a middle term.
Yeah.
And that's the term you tried to leave out, and that's the term everybody tries to leave
Mm-hmm.
out.
Yeah.
And the middle term only disappears when you're doing like difference of perfect squares.
Okay.
In other words, when you multiply a minus b times a plus b,
Uh-huh.
there's no middle term. It cancels. But
Okay.
that's the only situation I know of where you would not have some middle term.
Okay. That makes sense.
Okay? What is f of g?
So it'd be
Let's write it different.
okay.
If I say f of g, what does that really mean? F of what?
X minus 2.
Okay. And
Okay.
that's where you should always begin this problem.
Okay. Would it be 2? I mean, yeah. 2 and then
Well,
X minus
I
2?
don't know what it is yet.
Oh, gotcha. You have to
What's the
find it.
next step? What is f
Um,
of x minus 2?
um, fx minus 2f.
Well, no. What I
Or
mean by that is let's figure out what it is. And the next proper step, if f of x is 2x minus 4, what's f of 3?
um,
In other words, what's f of 3?
uh,
How do you solve for it? How do you figure it
oh, and yeah, you do 2 times 3 minus 4.
out? Okay? In other words, whatever's in the parentheses, you plug in for x.
Okay.
Okay, well, we're not doing f of 3. We're doing f of x minus 2. What is that?
Uh-huh. Um,
And do it
so
step
that
by
would be,
step. Spell it out, and then we'll simplify it. Do not try to simplify in the same step that you're writing.
okay. Um,
This is f of x.
Right.
What's f of x minus 2?
What would that?
What's the
Two,
rule? Whatever's in
two
the
times, two
parentheses,
times x minus 2?
there you go. Whatever's in the
Okay.
parentheses, you substitute wherever you see x.
Okay.
And that's what I just did.
Okay.
Now we have to distribute and simplify that. But you don't ever want to do that in the same step. I mean,
Yeah.
it's just too easy to make mistakes. So this
Right.
becomes 2x minus 4, which becomes 2x minus 8.
And
And you
that's your
want to do
answer.
it exactly like that. In other
Okay.
words, notice that I started with f of g of 8, x,
Mm-hmm.
excuse me. The first
Okay.
step was to just plug in g of x inside the parentheses, giving us
Okay.
this. And then once you get it to this step, it's just a question of wherever you see x in the f function, you plug in x minus 2.
Cool. All right.
Hold on, I'm finding myself with a need to erase because I don't want to rewrite both of those functions. Because there's so
Yeah.
many questions here that depend are involving these two functions.
For sure. Yeah.
I have to erase, but it seems to be working now.
Mm-hmm.
All right, hold on.
All right.
So we did 4. We did 1 through 4.
Uh-huh. Yeah.
I guess I could have erased, huh? Yeah. In other words, I didn't need these two. I thought there were still more problems to go.
Oh, no worries.
Not there. F of x is going to be 6x squared minus x to the 1/2.
Yeah.
G of x is going to be 2x to the 1/2. What's the sum of them?
So we would do 6x squared minus x to the 1/2 power. Okay. So let me write it down real fast.
Hold on. You do
Okay.
6x squared minus x to the 1/2.
Yeah.
And I'm going to add to that g of x plus 2x to the 1/2. Which of those terms can you combine?
Oh, whoops. Yeah. You could combine the minus x to the 1/2 power and then the 2x squared, or to the 1/2 power.
Yeah, what do you get when you
Squared.
combine these two right here?
You would get
1 and plus 2.
you just get x to 2 over 2, which is 1.
No, you're getting multiplication confused with addition. When I'm multiplying, you're right. You would add the exponents.
Okay.
But when I'm adding, you can only add things that have the same exponent.
Okay.
Now, think of that as apples, and that is apples, and this is oranges over here.
Okay.
I can
Here,
add
Mr.
the
Cow.
apples together. This is minus 1 apple. This is plus 2 apples. How many apples
Okay.
do we end up with? Minus 1
So,
plus 2
minus 1 plus 2, so that'd be 1.
plus 1.
Yeah.
You have to put the plus sign. Don't really need the 1. I can erase the 1, but I do have to have the plus sign.
Okay.
Okay, so that's what you get when you add.
Cool. And then that's your, no, that's not your answer.
Yeah, it actually
Or that is your
6x squared plus x to the 1/2. In other words, I
Okay.
cannot do anything more with that. They're not same. This is oranges, this is apples.
Okay.
If I was
Here, hold.
multiplying them, I could combine. In other
Okay.
words, if I had x squared times x to the 1/2, that would be x to the 2 and 1/2.
Okay.
So you have to always realize that you can do a lot more things with multiplication than you can do with addition and subtraction. And
Yeah.
that comes as a surprise to a lot of people. It's much harder to add and subtract than it is to multiply. And
Okay.
all you have to do is remember fractions. If
Uh-huh.
I'm adding those two, I gotta find a common denominator, and it's a hard problem. If
Okay.
I am multiplying those two, then it's an easy problem. I multiply numerators, I multiply denominators.
Okay.
Now, multiplication and division is always easier
Mhm.
than addition and subtraction, and that doesn't really, even with variables like this.
Okay.
It's true. Now,
Okay.
subtract them. What do you get?
All right. So let's see here. Um,
F of x minus g of x.
yeah. So you get 6x squared minus 3x to the 1/2 power.
Good.
Cool.
And multiply them.
Okay. Here, hold on, Mr. Count. I think our car alarm's going off. We parked our car outside. Let me just make sure it's
Sure.
not our car.
Yeah.
Sorry about that. Hold
No problem.
on. Okay, we're good.
Everything
Our garage door's broken, so we had to park our car outside. I was just making
huh?
sure
Okay.
no one was trying to get into that.
Yeah, really, for sure.
Yeah.
Although I don't
Yeah.
know that I'm not sure it would have been a good scenario if you'd encountered a car thief.
Oh, I know. I don't think that would be good. That
No,
would,
probably wouldn't be. You'd probably be in a struggle with somebody on your driveway, maybe for your life. Uh,
probably. Yeah. That's
so we're
not a
doing
situation you
f
want to
of
be in.
x times g of x.
Yeah.
Notice the first thing I did was switch them.
Mhm.
In other words, I got g of x times f of x, right?
Okay. Yeah.
The reason I did that is because it's easier thinking about this as distributing the 2x to the 1/2 to both terms. Excuse me, I got
Yeah.
kind of the hiccups.
You're fine.
So when I multiply that times that, what do I get?
You get 12x, and then yeah, it would just be 12x because the
Now you got
one
to
half
add
of the
the
number will
exponents.
cancel.
Remember, this is multiplication.
Right. So it'd be one
The
half
only thing
plus
that
2 over
allows us
1.
to multiply it is we have the same base, x.
Mhm.
So
So,
I need to add 1/2 and 2.
so it'd be yeah, one half plus 2 over 1, and then wouldn't that equal just 2 over 2?
No.
Or here, let
One
me do it
half
on
plus
paper.
2. No, I don't want you to do it on your calculator.
Oh no, I'm not. I'm doing it.
What's 1/2 plus 2?
Here, hold on.
I want you to think about it conceptually. It's clear to me you're not thinking about it conceptually. Otherwise, you'd had an answer 10 seconds ago.
Yeah, it'd be 5 halves.
Okay, what else would it be?
Um,
2.5, right?
sorry, you're kind of
I'm
cut out.
adding a half to 2. I got 2.5. And now I actually do prefer the 5/2 to the 2.5 as an
Mhm.
exponent. I'd rather see ratios than proper fractions. But
Okay.
the first thing you can do is that's 2.5. If I'm adding a third to 2, then that's 2 1/3. That's
Okay.
what addition basically does. All right, now what's the second term? When I distribute that to this term, what do I get?
Um, yeah, we get minus 2x. Yeah, just minus 2x.
Yeah, a half plus a half is 1.
Yep.
And that's going to be the answer. In other words, I could go through this answer and take a greatest common factor out
Mm-hmm.
of 2x, but that would be kind of silly. That would be doing the reverse of what we just kind of did.
Right.
So I'm sure they do not want you to do that.
I
Now,
doubt it.
let's look at the division of it.
Yeah.
Let me write it first to see if it's hard or easy.
Okay.
So we got f of x. Certainly f of x over g of x is easier than g of x over f of x.
Mm-hmm.
Only because we've got two terms in the numerator, which is much easier to deal with than two terms in the denominator. And
Okay.
this way, we only have one term in the denominator.
Okay.
So, first of all, what do I need to know that I can do here?
Um, well, since it's a fraction, you can add or subtract the exponents, or the fractions, or not the
If
fractions.
it was a monomial over a monomial, yeah, and I would
Okay. Yeah.
subtract the exponents. But
Mm-hmm.
right now, it's a binomial over a
Okay.
monomial.
Yeah.
1 second.
Okay.
Just closing the door.
Ah, no worries.
The first thing I have to realize that I can do is to separate this into two fractions.
Okay.
In other words, I have that fraction, which is 6x squared over 2x to the 1/2.
Uh-huh.
Subtract this fraction,
Three. Yeah.
which is x to the 1/2 over 2x to the 1/2.
Okay.
And now it becomes a pretty easy problem.
Mm-hmm.
Do it term by term. What's 6x squared divided by 2x to the 1/2?
Um, we would get 3x to 5 halves.
We're
Or,
dividing.
yeah.
What are we going to do with the
So,
exponents?
same switch flip, so it'd be 2 over 1 times.
We're
Oh, yeah.
subtracting. Remember, you never do with the exponents what you're doing with the base.
Okay.
We're dividing the base. So I'm
Yeah.
not going to divide the exponents, ever.
No.
I'm always doing one less level. What's
Okay.
one less level than division?
Um, multiplication.
Subtraction.
Is that, yeah, it is subtraction. Okay.
When I
So it
am
would be,
dividing the bases, I am subtracting the exponents. When I am multiplying the bases, I am adding the exponents.
okay.
Notice how what you do with the exponents is one level less than what you do with the bases. And that's all you
Okay.
have to remember. And you have to know that addition is one level less than multiplication.
Mm-hmm.
Subtraction is one level less than division. And
Okay.
multiplication is one level less than double exponentiation.
Okay.
So if I'm double exponentiating, I need to multiply the exponents together. So what's this exponent? What's 2 minus a half?
So, um, oh, 2 minus a half would just be
Minus
1.
a half. What is that?
1.
No. 2 minus 1
2.
would be 1.
Yeah. So that'd be
Well,
2.
let's make sure, I hate to see you struggle with these. There's no need
Yeah.
to struggle with these, but you've struggled with these for 3 years. And by
Yeah.
these, I mean where you have a fraction being added or subtracted from a whole number.
Mm-hmm.
There's no need to struggle with that. You have to
So
find
you,
a
oh yeah, with that you get 3. Yeah, you get 3 halves
right.
for
The
that.
common
Yeah.
denominator is 4
2.
halves. Instead of 2, I'm going to write it as 4 halves.
Yeah.
And that's what you always have to do, is
Mm-hmm.
find a common denominator, whether you have two fractions or whether you have a whole number and one fraction. As long as you're
Uh-huh.
adding or subtracting them, then you've got to find a common denominator. Now,
Okay.
what's the other part?
So it'd be 3x and 3 halves minus, um,
Hold on, no, it's x to the 1/2 divided by,
or,
oh,
yeah, no, I
2x to the 1/2. Yeah, okay, I see what you're saying.
know. Yeah. Um, so this one would be, um, would it just be minus 1/2 x?
Would just be minus 1/2.
No x, okay.
Here's the reason why. You divide the numbers, which gives you 1/2.
Uh-huh.
You subtract the exponents, right?
Mm-hmm.
You get that.
Yeah.
Well, anything raised to the 0 power is 1.
Right. So you don't.
So
There's no
that
need to
turns
put it
into
down.
1. But we didn't even need to know that. Anything divided by itself is 1. So
Okay.
it doesn't matter how complicated an expression I have. If I'm
Mm-hmm.
dividing it by the same thing, it's 1.
Okay.
In other words, if I had something like this, and I divide it by that,
Uh-huh.
that's 1. I don't need to do any factoring. I don't need to do any math. I'm dividing something by itself.
Right.
That makes it 1. I don't need the rules of exponents. I
Okay.
used them just to verify that that was 1. But
Mm-hmm.
basically what I really did was I canceled that, leaving 1 in its place.
Okay.
All right, so that's the answer
All
for
right.
number 8.
All right.
Okay, let's have a look at, hold on a second.
All right.
Okay, I'll rewrite these.
Okay.
F of x equals 3x to the minus 1.
Uh-huh.
V of x equals x.
All right.
Well, they start right off with f of g of x.
Yeah.
So tell me what's the first thing I should do?
So it would be f parentheses x minus 8.
Okay. What's that going to be equal to?
Um, or yeah, which is equal to um, would it be
It's real simple. Wherever you see x, plug in what's inside the parentheses. But you
where?
have to do it on that function, not the g of x function.
Right. So 3x to minus 1
Now,
power.
3, put parentheses in there.
Or 3, yeah.
And
And then parentheses.
in other words, that's all I did was plugged in x minus 8 wherever I saw x.
Okay.
Now, it's important that you know how to write this with a positive exponent
Yeah.
because they don't like negative exponents. In fact, I'm just looking now, and we haven't been answering the domain, uh,
Mm-hmm.
but we can for this one.
Uh-huh. Yeah.
So what is this equal to if I said do not give answers with negative exponents?
Would it be 1 over 3 parentheses x minus 8
Is the
to
3
the first power?
being taken to the minus 1?
No, it's not. So it's
Ah,
outside.
that leaves it in the numerator.
Yeah.
In other words, you could write it like this.
Oh, 3 over.
You're not
Okay.
wrong with the 1 over x minus 8, but the 3 goes in the numerator. You know,
Okay.
when I distribute it, that 3 no longer is a multiplier, just make it part of the numerator.
Right.
Okay? So that's the answer. Now, talk about domain.
So that's the answer to the problem.
That's the answer to f of g of x.
Okay. Alright. Cool.
Okay? But
Cool. Yeah, it
what's the
is.
domain of this function?
Um, would it be 0 to positive infinity?
Can x be 8?
It can. No, it can't. So it'd be
Remember what the
0.
first rule of mathematics is. Thou shalt never divide by 0.
Okay.
So when you're figuring out domain, that's
Mm-hmm.
always the first thing to look for, is what
Okay.
makes you divide by 0, and whatever that is, you can't do it.
Right.
So
So
what
it'd be
value
0.
of x would cause division by 0?
Negative.
Not negative, 8.
Uh, oh, that's so 0. Wait, so it'd be
X cannot be equal to 8 because if it were, then this denominator is 0.
Okay.
Okay?
Oh, that makes sense. Yeah.
So that's one domain restriction. Remember, domain is all about restrictions. Well,
Mhm.
when you have a composite function, you have to take the domain restrictions that are most restrictive.
All right.
Well, if we go back and we look at the f of x function, what else can x not be?
Um, can't also be three,
What I
right?
just circled. What can x
Three.
not be?
X can't be in the denominator.
3 over x.
That won't be. That's not a real number though. Like it can't be in the denominator, right?
Well, x
Or,
can't be 0.
right.
That causes you to violate the first rule of mathematics. That's
Okay.
always what you're looking for. So x cannot be 0 based on f of x,
Uh-huh.
and x cannot be 8 based on f of g of x. Now, in terms of g of x, there are no domain restrictions there.
No.
That can be all real numbers.
Mhm.
So what you have to do when you're dealing with composite functions and domain
Mhm.
is you have to take all restrictions. In other words, you have to take the restrictions of both f of x and g of x, and you have to take the restrictions of their composite function. In other
All
words, if I looked at just the individual functions separately, I would say, well, x can't be 0, but it can be anything else.
right. Mhm.
And that's true. But then once I'm taking a composite function, f of g of x, and I get
Mhm.
this thing that's 3 divided by x minus 8, well, clearly x cannot be equal to 8 either.
No.
And so x is the final answer for the domain is x can be all real numbers except 0 or 8.
Okay.
Always remember the domain is all about figuring out what x cannot be. Not what it
Okay.
can be. That's too hard because you're generally dealing with the whole number line. But
Right.
what it cannot be.
All
Because usually x is not that restricted. It's rare that it's restricted at all. It has to be in the denominator or under a radical sign pretty much.
Uh-huh.
Okay, now the second, number 10, wants g of f of x. So how am I going to
Yeah.
write this?
So you'd write that. So G. Um, it'd be G parentheses. X minus 8 is equal to
Yep.
um 3 parentheses x minus 8, right? No, 3x. Wait.
Hold on. Yeah, I was trying to figure out how we're getting the same answer here.
Yeah.
What's g of x minus 8?
um,
There's the g function.
right. And then it'd be 3 and then x to the minus 1.
Where are you getting the 3 from? There's no 3.
From F.
G of
From
x
F.
minus 8, I'm going to plug in x minus 8 wherever I see x.
Okay. Okay, that makes sense. Oh, that's where I was missing. Okay. Alright. So it'd be F and then x minus 8.
Now hold
Or,
on. Just do this right here. Forget the
oh,
f.
that's all
We're
you
done with the f.
have. Okay, that's all you have to
Just
do.
what is g of x minus 8? Here's g of x.
Uh-huh.
Happens, it's not g of x minus 8. I'm sorry, I didn't pick up your mistake.
Oh, you're fine.
What is g of f of x?
G f of x would be 3, and then x minus 1. Or x to the minus 1.
Okay, we have to do that. In other words, you can't not make a mistake, and we had made a
No.
mistake. So now what is g of 3x to the minus 1?
Um, it'd be G and then 1 over 3x to the
Hold on.
first. Right.
I want you to follow a methodology every single time that's exactly the same. If you do that, these are really easy.
Okay.
Whatever's inside the parentheses,
Uh-huh.
plug in for x. That's all you have to remember.
Okay.
Okay?
Right.
So,
Okay.
I've encountered an x. What do I plug in?
3x to the minus 1.
Okay, 3x to the minus 1, and I still have minus 8.
Yeah.
So that's the answer. It's just not simplified. Simplify it for me? Well, simplify it,
Yeah.
but it's got a negative exponent. They don't like
Yeah.
negative exponents.
No, so it'd be 1 over 3x to the first minus 8.
Remember, the 3 does not go in the denominator.
Alright.
It is
No.
not having this minus 1 applied to it. If I don't have parentheses like that,
Mm-hmm.
then remember the exponent only applies to what's directly beneath it if there are no parentheses.
Okay.
So the 3 stays in the numerator. What goes to
Yeah,
the
so
denominator?
so it'd be 3 parentheses 1 and then x minus 8.
Just x.
Or just x.
This thing right here is what I just wrote,
Alright.
minus 8.
Oh, okay.
See?
Uh-huh.
Okay. Now what's
Yeah.
the domain restriction of this function?
All real numbers except 3 and minus 8.
Nothing wrong with 3. 3
Or
divided
just
by
minus
3
8.
is 1.
Right. So all real numbers except for 8.
What can x not be? Look at this function right here. What's the number one rule in math?
Don't divide by 0.
What would cause me to divide by 0?
Um, if you divide it by x.
Okay. So what can
So,
x not be?
1. Well,
Now, if x were 1, I would have 3 divided by 1. There's nothing wrong with that.
no, 0.
Okay.
Except 0.
That's the
Yeah.
only answer.
Yeah.
And it's not hard.
No, that isn't hard.
And that's about as easy and basic as it gets. When you're
Uh-huh.
dividing by x, x cannot be 0. If I'm dividing by x minus 8, well, that's another degree of difficulty. Then
Right.
x minus 8 cannot be 0. But in this case, I'm only dividing by x. So x
Yeah.
cannot be 0, which was already a restriction from f
Uh-huh.
of x. So there's no additional restrictions. Remember the last problem, x couldn't be 8 or
Mhm.
x couldn't be 0.
Okay.
But this composite function
Uh-huh.
gives me what I've drawn a rectangle around here. And the only domain restriction of this answer here is x cannot be 0, which we already
Okay.
had, so that stays as a domain restriction.
Right.
All right.
Sweet.
Yeah,
All
we
right.
only got about halfway through, but if we're still working on
Got,
this Wednesday, we can finish it up.
yeah, I got a lot done there. So,
Yeah.
all right.
All
Sweet.
right. Talk to you
All
Wednesday
right.
night.
Sounds good. Thanks for scouting.
All right. Bye-bye.
All right. Bye.